Have you ever wondered what truth looks like when even the numbers feel incomplete? There's a Comet 3I Atlas drifting somewhere beyond the edge of the solar wind, and the story it carries isn't written in myths or starlight, but in ratios. Carbon dioxide to water 8:1, the highest ever recorded. And that changes everything we thought we knew about how a comet should behave. The data, you see, is correct, but perhaps the story is not. NASA confirmed it. The instruments on the James Webb Space Telescope saw it. Yet, in the press releases, in the news briefings, this detail, this anomaly, was treated like a whisper in a hurricane. Why? What makes a discovery like that fall silent in the halls of science? Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the map world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. Well, you see, it all began with a whisper from deep space, a small signature in the data, a flicker that most astronomers might have dismissed as noise. But noise, sometimes, has a rhythm. And in that rhythm, a pattern emerged, a chemical imbalance so striking that it refused to be ignored. The object was catalogued as 3I Atlas, an interstellar visitor sweeping through the outer edges of the solar system, and when its light was split into a spectrum, the numbers spoke in a language no one expected. Carbon dioxide to water, 8:1. That ratio alone might sound ordinary, until you realize what it means. In every comet ever studied, water dominates. Ice sublimates as the sun warms it, creating a ghostly coma, that soft, translucent halo we've seen in countless images. But here, in this alien wanderer, the roles were reversed. Water was scarce. Carbon dioxide was the voice that filled the void. It was as though this comet had been formed in a place where warmth never reached, where sunlight was nothing but a rumor. And that was the first hint, a clue, not about what 3I Atlas is, but where it came from. If the balance of gases is a fingerprint of birth, then this one was imprinted in a nursery colder than anything known within the reach of our Sunday. Perhaps beyond even the Kuiper belt, beyond the frost line, in some frozen chamber of the interstellar medium itself, NASA confirmed the readings, quietly. The James Webb Space Telescope, with its unblinking eye tuned to infrared light, observed it deliberately. That's the part that puzzled many scientists, because JWST's observation schedule is not a matter of chance. Every hour on that telescope is fought for, justified by months of proposals and reviews. For 3I Atlas to be granted time, it had to mean something. Someone knew there was more to see. When the spectra came through, the data didn't just confirm carbon dioxide dominance, it rewrote the expected chemistry of cometary formation. The models that predicted water ice as the main driver of cometary activity suddenly collapsed. You see, carbon dioxide sublimates at much lower temperatures than water. That meant 3I Atlas could come alive, outgas, form a coma, even far from the sun, in regions where ordinary comets sleep. And yet, there it was, shedding its gases with an intensity that defied the equations. At 129 kilograms of carbon dioxide per second, the outflow was extraordinary, a constant exhalation of ancient matter. Yet, curiously, there was no measurable non-gravitational acceleration. Normally, when a comet vents so violently, the escaping gases act like thrusters, pushing the nucleus off its predicted path. But not here. The motion remained smooth, almost perfect, as though the forces balanced in a symmetry too clean to be natural. And that, perhaps, was the second whisper. A few researchers began to murmur about the possibility of hidden mass, that the nucleus might be far denser than expected. Others suggested geometry, jets firing evenly from opposite sides, cancelling each other out. Both explanations worked on paper, and yet both required conditions so precise they bordered on improbable. Science, at its core, thrives on probability, but this was an outlier so extreme it felt like nature was mocking our confidence. Somewhere in those numbers, a riddle was unfolding. Now, you might think this would dominate headlines. Interstellar comet defies known physics. It sounds like the kind of headline that lights up every newsfeed. But the truth is quieter. NASA acknowledged the data, published it, and then moved on. The official press release trimmed the context, softened the language. Words like unprecedented or anomalous were nowhere to be found, even though the technical paper contained them in spirit. And that silence, that deliberate calm, became its own anomaly. One of the few voices to speak more boldly was Avi Loeb from Harvard, a name now tied to controversy and cosmic curiosity alike. He called it a major anomaly, hinting that perhaps 3I Atlas belonged to a lineage of interstellar objects, Oumuamua, Borisov, each rewriting what we thought was possible. Could this be another messenger, another fragment from a distant system carrying the chemical DNA of a different sun? Well, maybe, or maybe not. That's the tension that defines good science, the place between mystery and restraint. But let's return to the chemistry, because the chemistry doesn't lie. Alongside carbon dioxide, traces of nickel vapor and cyanide appeared in the spectral lines. Those aren't random contaminants. They're the fingerprints of complex, pre-planetary chemistry. Nickel implies metallic cores, the kind that form deep within, differentiated bodies, planets, perhaps, or moons. Cyanide, on the other hand, speaks to organic precursors, molecules that dance at the edge of life's definition. So what, exactly, is 3I Atlas? A comet? A fragment of something larger? The relic of a world that once had layers, crust, mantle, core torn apart and flung into the void? The coma, the shroud of gas around the nucleus, was immense, stretching 300,000 kilometers, nearly the distance from Earth to the Moon. And within that shimmering cloud, the density and shape of the gas flows formed strange patterns, like a controlled jet, not a chaotic spray. It's as if energy was being focused, channeled, guided. There's poetry in that idea, a frozen relic exhaling in perfect symmetry across the emptiness. Its orbit, too, was peculiar. Hyperbolic, yes, which means it wasn't bound to the sun, a visitor, not a resident. But it travelled within only 5 degrees of the ecliptic, the thin plane, where all the major planets orbit. Statistically, that's an improbable alignment, less than a 1 in 2,000 chance. Add to that its retrograde direction, moving against the flow of planetary motion, and the puzzle deepens. Was it simply a coincidence? Or had something or someone nudged its path long before it entered our neighborhood? Now, we must be careful here. Speculation is tempting, but science walks on the knife edge between wonder and evidence. Still, even the most skeptical researchers couldn't ignore the elegance of that orbit. It was too deliberate, too aligned, and yet nature does produce rare coincidences. Maybe this was one of them. The thing is, anomalies like 3I Atlas are mirrors. They reflect not only what we see, but how we choose to see it. Data itself is neutral. It's the stories we tell around it that shape belief. NASA didn't hide the numbers, they simply framed them differently. In science, framing can be as powerful as discovery. The deeper question, then, is not whether 3I Atlas is natural or artificial, ancient or engineered. It's whether our methods are capable of seeing truth when it refuses to fit our expectations. We build models, and when something defies those models, we call it an outlier. But what if, instead, the outlier is the model and everything else is the noise? When the James Webb Space Telescope shifted its gaze to capture 3I Atlas, the timing was deliberate. Observation slots like that aren't accidents, they're decisions. So somewhere in the chain of command, someone believed this comet mattered enough to interrupt a queue of hundreds of other projects. The data it returned confirmed that belief, but it also deepened the mystery. And as the comet passed near Mars, other instruments, the Trace Gas Orbiter, the Cassis camera, caught faint glimpses of its glowing coma. Rumors spread that the Perseverance rover, too, had caught a distant frame of it from the Martian surface. NASA neither confirmed nor denied. A simple yes or no could have settled it, but instead they chose the path of silence once more. And that silence echoed. Scientists began to wonder whether we were witnessing not a cover-up, but something subtler, a hesitation. The recognition that, sometimes, data arrives too early for theory to keep up. 3I Atlas forced a question we rarely ask aloud. What happens when our instruments see further than our imagination is ready to go? Its amorphous ices, untouched by warmth, told us that it had never been close to a star before. It carried within it the original texture of interstellar ice, chaotic, unprocessed, primordial. That makes it a relic from the dawn of star formation itself. But then comes the contradiction. If it had never been heated, why did it erupt so violently near the sun? Why did its gases burst forth with such energy, as though awakening from a long, deliberate sleep? Perhaps, I suppose, it's not the sun that woke it, but memory, the physical memory embedded in its structure, molecules rearranging, reacting, remembering a time before light. That sounds poetic, but in science, memory is a form of structure, and structure tells stories. Each hypothesis built to explain 3I Atlas required an unlikely chain of events: radiation stripping, hyper-cold formation zones, perfectly symmetrical venting patterns. The models stacked up like scaffolding around an invisible shape, a structure we couldn't yet see. And that's when the deeper truth began to emerge. Maybe it's not the comet that's strange. Maybe it's our assumptions that are incomplete. In the end, science is a dialogue between what we observe and what we expect, and here the dialogue faltered. Every explanation led to another question. Every certainty dissolved into another layer of doubt. And perhaps that's why the official narrative grew so quiet. Because what do you say when your data asks questions your models can't yet answer? The lesson, I think, is that mystery is not an enemy of science. It's the pulse that keeps it alive. 3I Atlas may be a comet, a relic, a messenger, or something else entirely, but what it truly represents is a mirror held up to our understanding, asking, how much do you really know? And how much have you simply assumed? And as it drifts now into the dark again, leaving behind its faint trail of carbon and silence, we're left with a feeling not of closure, but of invitation. Because out there, beyond the reach of the sun, beyond the tidy lines of our equations, something waits, something that bends the light just slightly wrong, that whispers through ratios and resonance. When we left 3I Atlas drifting through the dark, its tail fading into the cosmic wind, the silence it left behind wasn't empty, it was heavy, charged, almost alive. Astronomers turned their instruments elsewhere, the headlines shifted, and yet the data continued to whisper. You see, in science, anomalies don't disappear when we stop looking. They wait, they linger, like unspoken questions between old friends who both know the truth, but hesitate to say it aloud. And this interstellar visitor, had already defied too much to be forgotten. The next clue came not from brightness or motion, but from the light it reflected, or rather, how that light scattered. The spectrum showed traces of amorphous ice, the kind that forms when water molecules freeze so quickly they never settle into an ordered lattice. That kind of ice, you see, can only form in conditions far colder than anything within our solar system. It's like a fossil of the universe's earliest chill, preserved since the first atoms of oxygen and hydrogen began to bond. What startled the researchers was not just its presence, but its purity. The surface of 3I Atlas bore no signs of thermal alteration, no marks of ever having passed close to a star, which should mean it had spent all of eternity in the cold, and yet, when it neared our sun, it erupted with energy, venting gas and dust in a plume that dwarfed anything expected from such an ancient, frozen body. The contradiction was, again, total. A thing that had never known heat behaving as if it remembered it. Some began to suspect that the energy was not solar at all, that internal processes, perhaps radioactive decay, or the sudden collapse of pressurized cavities, might be responsible. But those processes too would require preconditions that didn't fit the object's observed composition. Others, more quietly, wondered whether external radiation, cosmic rays, high-energy photons had been absorbed over millennia, trapped beneath the ice, waiting for one spark of sunlight to release it all in a sudden breath. That image, I suppose, is haunting a frozen heart holding on to starlight for billions of years, then exhaling it all in one brief encounter with warmth. The coma that formed around it was enormous, almost beyond comprehension. A sphere of gas, 300,000 kilometers across, delicate yet structured, its inner flows tracing strange geometries, arcs, waves, spirals, as though something inside was orchestrating the release. Gas dynamics usually form turbulence. This one formed patterns so precise that, for a moment, even the algorithms used to model it failed to converge. They had to be rewritten. And that's when a new kind of question appeared. When natural laws seem to hold, but the behavior looks designed, what do we call that? Coincidence? Harmony? Or intention? I'm not saying, of course, that 3I Atlas was built. That would be foolish. But perhaps, and it's only a thought, perhaps the line between constructed and emergent is thinner than we think. Nature has a way of mimicking intelligence when conditions are just right. Crystals grow in perfect symmetry. Magnetic fields form shapes that seem deliberate. Maybe this comet was simply another expression of that quiet order that hides beneath chaos. Still, there was something else. The orbit. Hyperbolic, yes, but nearly coplanar with the ecliptic within 5 degrees. Statistically, that's improbable to the point of absurdity. Most interstellar visitors come in at random angles, obeying no pattern, tracing paths that cut across the solar system like stray threads. But 3I Atlas glided in along the same thin plane where our planets dance, as though it had known where to find us. Its trajectory was retrograde, moving against the flow of everything else, and yet aligned with uncanny precision. If you ran the numbers, the chance of such a path occurring naturally was about 1 in 2,000. Not impossible, but almost defiant. Some called it luck, others a message. NASA, though, said little. The official statements were cautious, elegant, even but void of emotion. Consistent with interstellar origin. No indication of artificial composition. Further analysis ongoing. That was the tone. Factual, sterile, safe. But between the lines, in the silence after those phrases, something else was felt. The unspoken acknowledgement that not all puzzles are meant to be solved at once. Meanwhile, smaller teams across Europe and South America began to publish independent analyses of the same data, and their findings aligned. The chemical ratio held, the absence of acceleration held, the orbit held. Everything was consistent, but consistency itself became the problem. When all your variables agree yet reality feels wrong, you're forced to ask whether the model, not the universe, is the flaw. And that, well, is where science becomes philosophy. Because maybe what's breaking isn't the data, but our narrative. We like to think of comets as ancient time capsules, fragments of ice and dust tracing the history of star formation. But what if some comets are older than that story? What if they're fragments not of solar systems, but of interstellar chemistry itself, raw material from before the stars learned to burn? If 3I Atlas was one of those, then we were witnessing not a visitor from another world, but a messenger from a time before worlds existed. Its carbon dioxide dominance, its lack of crystalline structure, its symmetry all could be relics of a pre-stellar age, a time when gravity had not yet carved matter into planets, when the universe was still sifting its ingredients. And yet, the presence of nickel vapor complicated everything. Nickel doesn't form in molecular clouds. It forms in the hearts of stars, under pressures so immense they forge elements from the bones of light itself. That meant 3I Atlas had once known the inside of a star, or at least the ashes of one. A contradiction upon a contradiction, a body both primordial and post-stellar. The mind reels, doesn't it? It was as if the object carried two birth certificates, one from the dawn of chemistry, another from the death of a sun. And then came the cyanide, CN signatures scattered across the spectra, faint but unmistakable. Cyanide, the molecule that in the right balance becomes the seed of amino acids, the chemistry of life's earliest whispers. In that moment, 3I Atlas stopped being just a comet. It became a question about origins, not only of systems, but of possibility. Could life, or its precursors, travel like this frozen, silent, drifting for eons until finding a star to warm them awake? Perhaps that's too romantic a thought for most scientists. But then again, so was the idea of life itself, once. You see, there's a strange humility in realizing that every comet is, in a way, a storyteller. Each carries a record of where it's been, what forces shaped it, what memories it holds in its molecular bonds. And yet, we interpret those stories through the limits of our own language, our own physics. Maybe that's why anomalies like this, one, feel uncomfortable. They remind us that the universe does not have to explain itself in human terms. Around that time, whispers began to circulate, nothing official, just small notes exchanged between researchers. There were hints that the Mars orbiter, the Trace Gas Observatory, had captured clearer images of 3I Atlas's coma, not publicly released, of course. The data was said to show unusual polarization patterns, light scattered as though by dust particles aligned in a magnetic field. Comets don't normally display such coherence. It was like watching an orchestra play without a conductor, yet somehow the notes aligned. The Perseverance rover, stationed far below on the Martian surface, was rumored to have glimpsed it too, a faint streak across the thin sky, caught during one of its long-exposure calibration tests. NASA, as always, neither confirmed nor denied. And that silence, once again, spoke louder than any statement could. It made people wonder, what does it mean when the institutions that shape our understanding choose quiet over clarity? Not deceit, necessarily, but perhaps caution or reverence, because sometimes, I think, even scientists feel awe. In the months that followed, the conversation around 3I Atlas drifted from data to doubt, from measurement to meaning. Some called it the black swan of the solar system, an event so rare it forces us to question the framework itself. And maybe that's the point. Every era of science has its black swans. Galileo had his moons of Jupiter. Einstein had his bending starlight. Ours, perhaps, is a comet that doesn't fit. But here's what fascinates me most. The further we look into the universe, the more we find that its deepest mysteries are not hidden in distant galaxies or dying stars, but in small, unassuming fragments like this, a rock, an ice ball, a flicker of gas, the ordinary, under enough magnification, becomes miraculous. So perhaps the question is not, what is 3i Atlas, but what does it reveal about us? About the way we handle uncertainty, the way we tell stories around truth. Maybe NASA didn't suppress the story. Maybe they simply feared that wonder, misused, becomes noise. And yet, silence has its own dangers. It leaves room for speculation, for imagination to fill the gaps. And sometimes, imagination is what science needs most. As 2025 approached, new telescopes prepared to open their eyes, the Vera Rubin Observatory among them, ready to scan the sky with unprecedented precision. Some said it might find more interstellar visitors, others doubted it. But in quiet corners of conference rooms and observatories, scientists still spoke of 3i Atlas with a kind of reverence, like a question that refuses to close. Because deep down, they knew that the story wasn't finished. The comet was gone, yes, but its trail, chemical, philosophical, emotional, still hung in space, invisible but real. A line of thought, stretching from our instruments to our imagination. And somewhere, perhaps, in that thin veil between data and wonder, another signal waits, faint, persistent, calling us to look again, to listen harder, to dare another question. And somewhere, perhaps, in that thin veil between data and wonder, another signal waits, faint, persistent, calling us to look again, to listen harder, to dare another question. Because, you see, the more scientists looked at 3i Atlas, the more they realized that its greatest mystery was not what it was made of, but what it refused to do. When a comet vents gas at such a furious rate, it should move. The mathematics is clear. Every jet, every burst of carbon dioxide is like a tiny thruster, pushing the nucleus off course. Yet when astronomers tracked its motion, it followed the predicted path with unnerving precision. No drift, no deviation, no measurable non-gravitational acceleration. It was as though the universe itself was holding it, steady, or as if it had found a way to counterbalance the very forces that should have torn it apart. That's when the whispers began about symmetry, perfect symmetry. The idea that the vents across its surface were so evenly distributed that every exhalation met its opposite, but the odds of such balance occurring by chance are astronomically small. Nature, elegant as she is, rarely works in perfect lines. There's always a tremor, a tilt, a breath of chaos in the design. So what then could hold it so still? Was it mass and unexpected density, a metallic core buried beneath layers of ancient ice? The presence of nickel vapor seemed to suggest it. Or was it something subtler, a structure within, crystalline perhaps, capable of redistributing stress and maintaining equilibrium? The deeper the analysis went, the stranger the conclusions became. Some argued that it must be heavier than expected, so dense that its own inertia swallowed the effects of outgassing. Others proposed that its shape, unseen beneath the coma, might be spherical in a way few comets are, perfectly round, perfectly centered, but that too was rare. Comets, like memories, are shaped by collisions and loss. They are fragments, not spheres. And yet, 3i Atlas refused to fragment. Even as it neared the sun, even as heat tore through its crust, there was no sign of breaking, no irregular spin, no erratic brightening. It behaved, for lack of a better word, with intention. Of course, intention is a dangerous word in science. It implies will, purpose, qualities that belong to minds, not molecules. But then again, the history of discovery is full of moments when language failed before understanding arrived. Maybe it wasn't intention. Maybe it was something simpler, stability born of a structure we haven't yet imagined. By this time, data from the James Webb Space Telescope was being cross-checked with readings from the European Southern Observatory and the Hubble archives. The MAVA, spectral lines of carbon dioxide, nickel, and cyanide were confirmed beyond doubt. What unsettled the teams was the absence of water, not just a scarcity, but a void. The usual signatures of hydrogen and oxygen emissions were faint to the point of invisibility. It was, chemically speaking, a desert in space. And that created a paradox. Comets are, by definition, icy. They are the carriers of water, the bringers of oceans. Without water, what are they? The models began to collapse. Some postulated that it had formed in an environment so cold that water froze into amorphous glass, trapping volatile gases beneath. Others imagined that radiation from nearby stars had stripped its water away, leaving only carbon compounds. Both scenarios were possible, but both were improbable to the point of discomfort. That discomfort, well, it's the heartbeat of science. It's the silence that follows a question too big for the instruments built to answer it. You see, what's beautiful and terrifying about 3I Atlas is how it forced us to confront the limits of our own equations. When everything fits except the feeling that it shouldn't, we are left with philosophy disguised as physics. Why does symmetry exist at all? Why does matter sometimes choose order when chaos is easier? Perhaps that's the deeper mystery. And then there was the orbit, a trajectory so finely tuned it bordered on the improbable. Hyperbolic, yes, which means it came from beyond the sun's grasp. But its inclination, only 5 degrees from the ecliptic, placed it almost exactly within the plane of our planets. That's like tossing a grain of sand across a desert and having it land on the edge of a single hair. Retrograde motion, nearly perfect alignment statistically, a 1 in 2,000 chance. Coincidence, perhaps. But coincidences of this magnitude have a way of unsettling certainty. They remind us that probability is not the same as impossibility. Still, some in the community began to whisper of trajectory shaping, not manipulation exactly, but the idea that its path had been influenced long before it reached us. By what? No one could say. A past gravitational encounter? A disrupted binary system? Or something older, more deliberate, from a time when physics itself might have danced to a different rhythm? NASA's official reports remain neutral. Their tone was clinical, detached, the language of science stripped of wonder. Yet, between the footnotes and tables, you could sense hesitation. Phrases like non-typical behavior and requires further analysis appeared again and again, each one a quiet admission that the known universe had stretched just a little further than we were ready for. Meanwhile, Avi Loeb and his team at Harvard published their own paper, calling the object a major anomaly. The term itself became controversial. Some called it sensationalism, others honesty. Loeb argued that when something defies our models, we must be brave enough to call it what it is, unexplained. And that, perhaps, is where courage begins in science, not in the discovery, but in the refusal to pretend we understand. Yet the most curious thing wasn't the disagreement, it was the silence. NASA didn't refute Loeb's claims. They didn't endorse them either. They simply said nothing. No public debate, no press conference, no correction. And in that absence, a new kind of tension was born, not between fact and fiction, but between truth and narrative. Because, you see, there's a difference between withholding data and withholding meaning. The numbers were all there, published in the Astrophysical Journal, open to anyone who cared to read them. But the story, the emotional weight of what those numbers implied was missing. A comet that broke the rules, that behaved like a relic of another physics, deserved to be spoken of with awe. Instead, it was filed away, its strangeness dulled by the machinery of communication. The press release described it as scientifically interesting. A phrase so modest, it bordered on absurdity. And that's when a quiet rebellion began, not in labs or boardrooms, but in conversations, online discussions, the late-night musings of astronomers who couldn't let it go. They started sharing images, recalculating orbits, replotting light curves. They asked, again and again, why was this not celebrated as the marvel it was? One possibility was simple: timing. The world in 2025 was noisy, full of crises and noise, and perhaps a distant comet, however extraordinary, could not compete with the chaos of Earth. But another explanation was more unsettling: that institutions, weary of speculation, had grown cautious of wonder itself, because wonder, if left untended, can slip easily into myth. And yet, isn't that where discovery always begins? In that space where awe meets ignorance? As 3i Atlas faded from view, the data lingered, and new analyses began to peel away layers no one had seen before. They found traces of metallic vapors interacting with cyanide, forming transient compounds that shouldn't survive in space but somehow did. They found that the coma's internal structure wasn't uniform. It pulsed, faintly, rhythmically, like breathing. The frequency matched no known rotation rate, no thermal cycle. It was just there, repeating, patient, indifferent to interpretation. A signal, some said. A resonance, others countered. But in truth, no one knew. Perhaps, I suppose, it was both the rhythm of chemistry and the illusion of intent intertwined. Because that's what nature does. It writes messages we're not yet fluent enough to read. By the time it passed beyond Mars, instruments on the Trace Gas Orbiter and the Cassis camera had caught only faint shadows of its glow. The nucleus itself remained invisible, hidden behind its luminous veil. Rumors spread that Perseverance, the rover resting in Jezero crater, had captured a thin streak of its tail against the Martian sky. A rumor, nothing more. NASA's response was a single line: no comment, and the silence deepened. Somewhere between those denials and delays, a truth began to form, not about 3i Atlas, but about us, about the way we handle the unknown. Science, for all its precision, is still a human act. We choose what to emphasize, what to share, what to frame as ordinary. Maybe NASA wasn't hiding anything. Maybe they were protecting something: our sense of certainty, our fragile belief that the cosmos is still predictable. But the universe, you see, has never promised to be simple. The further 3i Atlas drifted, the more it felt like a mirror held to our own limitations. Every anomaly, every unanswered question was less about the object itself and more about our need to categorize what we don't yet understand. And perhaps that's the most profound lesson of all, that the boundary between science and silence is not built of facts, but of fear. As months passed, its trail thinned and vanished into interstellar night, and yet something of it remained, not in telescopes, but in the minds of those who had glimpsed it. In late meetings and midnight calculations, in the quiet conviction that we had seen the edges of something immense. And somewhere out there, beyond the orbit of Neptune, beyond the reach of our light, the story of 3i Atlas continues, faint, persistent, unfinished, a story not of discovery, but of invitation. Because for every question it left behind, another seems to rise, like the shimmer of a distant reflection, leading us further into the dark. And perhaps, if we're listening closely enough, toward the beginning of something even stranger. And perhaps, somewhere beyond the reach of our telescopes, that faint thread of carbon and silence continues to drift, a message carried not through words, but through the quiet defiance of its own existence. Because by the time the last signal from 3i Atlas faded into the background hum of the cosmos, what remained was not an answer, but an unease. A sense that something in our understanding of nature had been slightly, imperceptibly tilted. The official reports closed neatly, as they always do. The data was catalogued, archived, and filed under non-periodic comet. Its motion plotted, its chemistry logged, its anomalies noted but left unexplained. The system, you see, has a way of digesting even the extraordinary, turning astonishment into routine. But beneath the calm surface of those summaries, the real story continued to ripple through observatories and late-night research sessions. There were too many inconsistencies, too many silences. Take the most curious of them all, the moment when the James Webb Space Telescope turned its gaze, not by chance, but by design. The observation window for JWST is among the most competitive in all of science. Proposals are reviewed, debated, ranked, and most are rejected. For 3I Atlas to receive dedicated time, it had to pass through layers of scrutiny that eliminate anything uncertain or trivial, which means someone somewhere decided that this object mattered more than most. And yet, when asked why, the official documentation gave only vague reasoning: to study early solar system analogues. But 3I Atlas is not part of the solar system, it's interstellar. Its chemical ratios are alien. The phrase, harmless at first glance, carried a quiet contradiction. It was as though the proposal itself had been written to sound conventional, to slip unnoticed through bureaucratic corridors that might otherwise resist the strange. During that scheduled observation, JWST captured its most detailed infrared spectra. Every photon of light that left the comet's coma carried with it a fragment of truth, and together they painted a picture that defied every model we had. The dominance of carbon dioxide, the faint traces of nickel vapor, the eerie silence where water should have been. Those numbers weren't merely data points. They were dissonant notes in a cosmic symphony, tones that didn't belong to any known melody. When those results arrived at NASA's analysis teams, something unusual happened. For days, no one spoke publicly. The internal communication logs, later released under routine transparency policies, showed a flurry of private correspondence, brief, cautious, and often inconclusive. Spectral consistency confirmed, one message read. Another, thermal model cannot reproduce activity curve. And finally, a line that would later be quoted, half-jokingly, by researchers who still remember that week. Data correct, story incomplete. That phrase became a kind of ghost that haunted the discussion ever since. Because what do you do, really, when the story refuses to match the evidence? The more they looked, the stranger it became. The layers of amorphous ice on the surface, untouched by heat, proved that it had never approached a star. It was, by all definitions, primordial, an object that had drifted unaltered since the earliest whispers of the universe. And yet, when sunlight reached it, it came alive with violent beauty, releasing carbon dioxide with the force of a living thing exhaling after eons of sleep. There was a hypothesis that perhaps, long ago, it had once belonged to another system, ejected during the chaotic dance of planetary formation. But that would require conditions so specific, so mathematically improbable, that it strained belief. You'd have to imagine a planet-sized collision, perfectly aligned to hurl a small body outward with enough velocity to escape its home star and travel across interstellar distances without disintegration. Possible? Yes. Likely? No. And that improbability deepened with its orbit. The eccentricity of 6.2 placed it on a hyperbolic trajectory, confirming it wasn't bound to our Sunday. But the angle just 5 degrees from the ecliptic was like an echo of intention. Space is vast, random, chaotic, and yet here was an object moving through the same narrow plane that cradles the orbits of Earth, Mars, and all the planets. It was as if it had aimed to be seen. Some researchers spoke privately about directed probability, a mathematical way of acknowledging coincidence without invoking purpose. Others, more poetic, called it choreography, the universe's subtle way of arranging patterns that look like design but are really chance. And yet, in every quiet conversation, the question lingered. What if it wasn't chance? Even the way it outgassed was peculiar. Most comets release jets unevenly, creating wobbles in their motion. But 3I Atlas exhaled evenly in all directions, its coma expanding in a sphere so symmetrical that the models of gas dynamics had to be rewritten to fit it. The flow lines were smooth, not chaotic. The distribution of density followed gradients too precise to be explained by random sublimation. One researcher described it as engineered thermodynamics, a phrase quickly redacted from official correspondence. When those findings reached the media teams, the tone changed. The press release softened the language, replaced words like unprecedented with notable. The anomaly became an interesting feature. The complexity of chemistry was rewritten as unexpected variation. Each edit removed a layer of astonishment until what remained was something safe, digestible, almost dull. But science is not meant to be safe. Behind closed doors, the conversation continued. Some argued for releasing the full data, to let the world share in the wonder. Others urged restraint to wait, to gather more evidence, to avoid fueling speculation. Because speculation, especially in an age of noise, is dangerous. It spreads faster than truth. And so, NASA chose silence. Not denial, not deceit, just silence. Meanwhile, independent observatories began sharing their own results, and the inconsistencies grew louder. European teams confirmed the strange ratios. The Atacama telescope in Chile recorded faint emissions matching those seen by JWST. Even amateur astronomers noticed the peculiar steadiness of its brightness curve. No spin, no flicker, no irregular shadowing. By then, a new pattern had begun to emerge, one that connected 3I Atlas to a broader mystery. The interstellar visitors we had encountered before, Oumuamua and Borisov, each carried their own puzzles, one shaped like a shard of metal, tumbling without a coma, the other ordinary in composition but extraordinary in trajectory. Together they formed a triad of questions about what really drifts between the stars. Are these relics of dead systems, or something more deliberate remnants of technologies older than our imagination allows? No one dared say it outright. The idea of an artifact, even hypothetically, sits on the edge of science. But the similarities between them, their rare orbits, their non-typical chemistry, their improbable stability, were too neat to dismiss entirely. Still, not all mysteries demand an otherworldly answer. Sometimes they simply remind us of how much we have yet to learn. Perhaps 3I Atlas was a fragment from a primordial cloud, shaped by radiation from ancient stars. Perhaps its symmetry was the natural outcome of unknown thermodynamic properties of interstellar ice. The truth, in the end, may lie somewhere between miracle and math. But what mattered most was what it revealed about us, about our institutions, our fears, our reverence for order. We build frameworks to make sense of chaos, but when the universe delivers something that doesn't fit, our first instinct is not to question the framework, it's to hide the anomaly within it. And that's the real story of 3I Atlas. Not the ratios or the orbit or the gases, but the silence that surrounded it. A silence that was both human and cosmic, as though the universe itself had paused to listen. When I think of it now, I imagine the object still moving, quiet and unhurried, through the deep. The gases long gone, the glow extinguished, the core drifting between stars carrying within it the secrets of its impossible birth. And I can't help but wonder whether, one day, another observer in another system will see it and ask the same questions we did. Perhaps they, too, will feel that same unease between the numbers and the meaning. because every anomaly, in time, becomes an invitation. And somewhere beyond the reach of our certainty, another one is already approaching, faint, silent, waiting to be seen. And somewhere beyond the reach of our certainty, another one is already approaching, faint, silent, waiting to be seen. The universe, you see, has a peculiar rhythm. Just when we begin to believe we understand its patterns, it offers something that doesn't belong. It reminds us, gently but firmly, that knowledge is not a destination but a motion, a slow unfolding, an orbit around truth that never quite closes. 3I Atlas was such a reminder, an object that existed precisely in the space between explanation and awe. And though its light has long faded from our telescopes, the questions it raised still burn, faintly, like embers in the collective mind of science. For months after it vanished into the dark, the data continued to confound analysts. Every recalculated trajectory, every refined mass estimate, led to the same impossible conclusion. The numbers refused to agree. Based on the rate of carbon dioxide escape 129 kilograms per second, the comet should have experienced measurable acceleration. The absence of that acceleration suggested one of two things. Either the object was vastly heavier than predicted, or its outgassing was so perfectly balanced that every vector of force cancelled the others with impossible precision. Both explanations strained belief. The first required a density far exceeding that of rock or metal, a composition inconsistent with its observed spectrum. The second demanded symmetry so absolute that even computer simulations failed to reproduce it. Comets, by their nature, are chaotic. Their surfaces are fractured, their spin uneven, their jets sporadic. But 3I Atlas behaved like something engineered to defy those expectations. It was as if nature, for a fleeting moment, had chosen to imitate geometry. Astronomers, cautious as ever, avoided the word impossible. They called it non-typical, statistically rare, model-resistant. But underneath that clinical language, there was wonder. You could hear it in the pauses between their sentences, in the hesitations during interviews. It was the sound of curiosity wrestling with disbelief. And then came the metal. Nickel vapor, faint, but unmistakable, shimmering in the spectral data like a buried signature. It shouldn't have been there, not in such concentration, not without iron or cobalt to accompany it. Nickel appears in planetary cores, forged in furnaces of pressure and heat. Its presence suggested layering, differentiation, the signs of a world that once melted, separated, evolved. That revelation transformed 3I Atlas from a comet into something far older, far more complex. Perhaps it was a fragment of a broken planet, or the cooled heart of a body that once circled another star. Alongside the nickel came cyanide CN, the fragile molecule that teeters on the edge of organic chemistry. In most comets, it's a trace component, a leftover from the primordial soup of the solar nebula. But here, it was strong, pronounced, almost proud. Cyanide is paradoxical, toxic to us, yet essential to the chemistry of life. It's one of the molecules that bridge the inanimate and the animate, the mineral and the living. And so the question grew larger. Was this thing merely ancient, or was it ancestral? Because if 3I Atlas carried the ingredients of life, even in trace amounts, then somewhere in the vast cold between the stars, the seeds of biology were adrift long before our sun was born. It was a comet, yes, but also a story about possibility, about how life might not be a local accident but a cosmic habit. And yet, for all its promise, something about it remained uncomfortably mechanical. The coma, that luminous shroud of gas, expanded with eerie precision, its density gradients tracing perfect curves. Even the way light scattered within it followed equations too exact to be natural. The models that predicted random jets and turbulence had to be rewritten. One astrophysicist described it as a conversation between matter and mathematics. But perhaps the strangest discovery of all came from the coma's shape. Using polarimetric imaging, scientists reconstructed the distribution of gas around the nucleus. What they found was not a chaotic cloud, but a faintly structured halo layers, almost concentric, as though the gas were escaping through invisible rings. Each layer had its own brightness profile, its own rhythm. It looked less like an explosion and more like a breathing pattern, a pulse. That rhythm was slow, deliberate, almost biological in tempo, one full cycle every few hours. Too slow to be rotation, too regular to be random. It was, as one researcher admitted off record, the kind of symmetry that feels intentional. But intention is not a scientific term, so the observation was buried in appendices and left unexplained. You see, science is not afraid of mystery, but it is uneasy with meaning. Meanwhile, other teams focused on its motion. Its trajectory through the inner solar system, though hyperbolic, aligned with the ecliptic so precisely that the odds of such coincidence were vanishingly small. 5 degrees of inclination, retrograde, motion, near perfect intersection with the plane of planetary orbits. On paper, a 1 in 2,000 chance. In the heart, it felt like a message. When asked about this during a press briefing, a NASA spokesperson smiled and said, "The universe is full of coincidences, and perhaps it is. But sometimes, coincidences are just names we give to patterns we don't yet understand." As the weeks passed, amateur astronomers began comparing 3I Atlas's orbit with those of earlier interstellar visitors Oumuamua and Borisov. A pattern began to emerge. Each had entered from the same general quadrant of the sky, near the solar apex, the direction in which our sun moves through the galaxy. Statistically, that made sense. We would be more likely to encounter objects from that direction. But taken together, it felt like a trail, as if these were not isolated wanderers, but fragments of a greater stream, relics of a long dispersed civilization of ice and metal drifting in formation across the void. It was Avi Loeb's group at Harvard who gave voice to that quiet speculation. They published a short paper titled Major Anomaly, arguing that 3I Atlas, like Oumuamua, might represent a new class of interstellar object, not random debris, but technological remnants. The media seized on the word technological, twisting it into something sensational, and the story ignited across headlines. NASA said nothing. Silence, once again, became the only response. Perhaps it was caution, perhaps it was fatigue. The institution had learned that wonder is a dangerous currency in the modern age. But for those who had seen the raw data, the silence felt like avoidance. Not denial, simply an unwillingness to face the magnitude of the unknown. And then there was Mars. During its closest approach to the red planet, several instruments, the Trace Gas Orbiter, the Cassis camera, even the Perseverance rover, recorded faint traces of the comet's coma. The images were blurred, barely distinguishable from background noise, but unmistakable in their timing. And though NASA never confirmed or denied their authenticity, internal documentation hinted that more data had been collected than released. A simple statement could have dispelled the rumors. Instead, there was nothing. One scientist compared the silence to that of deep space itself, not deceitful, but vast, indifferent. You see, perhaps the real paradox isn't in the comet, but in us. We crave truth, yet we fear its implications. We demand evidence, yet when the evidence points towards something unfamiliar, we retreat behind language, calling it unverified, inconclusive, premature. 3I Atlas became not just a physical anomaly, but a mirror held up to the culture of science itself, and in that reflection, an uncomfortable thought emerged. What if this was not an isolated event, but the beginning of a pattern? What if these interstellar visitors are not accidents, but emissaries of a larger cosmic process. The universe seeding itself with complexity, scattering blueprints of chemistry and consciousness across time and distance. It's tempting, of course, to imagine intelligence, to think of deliberate design. But maybe intelligence is not a mind but a pattern, and the universe itself is thinking through matter. Maybe 3i Atlas was part of that thought, a brief flicker in the long sentence the cosmos is still writing. And so, as 2025 drew on, the comet faded beyond detection, leaving behind a legacy of confusion and wonder. Some scientists moved on, others couldn't. The data kept whispering. Ratios that didn't fit, light curves that refused to fade completely. A faint residual glow, recorded by infrared sensors long after it should have vanished. Was it noise? Probably. But then again, so are most beginnings. Late one night, as Earth turned quietly under the stars, an astronomer at a small observatory in the Andes noticed a faint object entering from the same direction 3i Atlas had come. The signature was dim, fragmented, barely traceable. But the orbit was eerily familiar. And perhaps, if the universe was listening, that was its way of speaking again. A whisper, just at the edge of understanding. A second visitor, carrying the same strange silence with it. A whisper, just at the edge of understanding. A second visitor, carrying the same strange silence with it. That was how it began again, not with an announcement, not with a discovery broadcast across the world, but with a quiet entry in a logbook. A small flash in the sky, recorded by an automated telescope in the Andes. The object was faint, almost imperceptible, and yet its motion was clear. Another hyperbolic trajectory, another visitor from beyond. In the early hours of that cold morning, a researcher looked at the data and froze. The orbit was eerily familiar within a fraction of a degree of past. The path 3i Atlas had taken less than a year before. It was as if the universe had pressed rewind. The news spread quickly through private networks of astronomers, whispered in coded messages and late-night emails. Possible repeat event, one wrote. Identical parameters within margin. The tone was careful, cautious. Nobody wanted to make the same mistake twice. But the excitement was there, the quiet thrill of knowing that the cosmos had, once again, chosen to speak in riddles. When the first spectra arrived, the scientists felt that same shiver they had known before. The chemical ratios were nearly identical. Carbon dioxide, dominant and defiant, water trailing faintly behind. The numbers were impossible to mistake. It was like hearing the same song played by a different instrument, familiar, but changed, echoing the memory of something that should have been unique. And that's when the questions began to multiply. What were the odds that two interstellar objects would share not only composition but trajectory? Was this the signature of a single event, fragments of a larger body, perhaps, drifting through the galaxy together like scattered memories of one long-forgotten catastrophe? Or was it something else, something patterned? A few dared to voice what others only thought. What if 3i Atlas wasn't alone because it was never meant to be? NASA remained silent at first. The lessons of the previous year had been learned well. Public statements would come only after verification, after the noise had been filtered from the signal. But inside the agency, discussions grew tense. There were those who believed the resemblance to 3i Atlas was coincidence, an illusion conjured by statistics. Others whispered that it was too perfect, a symmetry not just of chemistry, but of circumstance. And then, the light curve changed everything. The new object, provisionally named 4i Solis, displayed a brightness variation that seemed, at first, random. But as data accumulated, a rhythm emerged. Small pulses of luminosity, regular and persistent, like a heartbeat buried beneath the static. Every 4 hours, the The signal rose and fell with uncanny precision. It wasn't rotation, it wasn't thermal variation, it was something else, a modulation that no natural process could yet explain. One researcher at the European Space Agency described it quietly as the most unsettling data set I've ever seen. Not because it was alarming, but because it was deliberate. Every measurement, every ratio, every curve seemed to point toward structure, toward coherence. And coherence, in the language of the cosmos, is the signature of design. But of course, science does not move on suggestion, it moves on replication. So telescopes across the world turned their eyes to 4I Solis. JWST was scheduled for another observation, its infrared instruments ready to dissect the faint glow. Meanwhile, radio observatories scanned for emissions, searching for patterns that might indicate magnetism or communication. None were found, only the soft hum of carbon dioxide drifting through space. Still, the symmetry refused to fade. The comet's coma, vast and structured, expanded again into perfect gradients, its density profile following curves that matched those seen in 3I Atlas. And once more, there was no measurable acceleration. The jets that should have pushed it off course seemed perfectly balanced, as though it were holding itself still in defiance of motion. And that's when the pattern became undeniable. Two objects, from two different entries into our solar system, following the same improbable path, sharing the same improbable chemistry, and behaving with the same improbable precision. The statistical probability of such repetition was so small that even the most skeptical minds had to pause. For a brief moment, science itself hesitated. Avi Loeb, ever the provocateur, published a short essay calling it Confirmation of an Interstellar Sequence. He argued that both 3I Atlas and 4I Solis might be fragments of a single parent body, perhaps an ancient interstellar probe, long dead, decaying slowly as it crossed the galactic plane. It was an idea that skirted the edge of acceptability, too bold for most journals but too intriguing to ignore. Others proposed something more subtle, that these were survivors of an ancient planetary system, ejected together when their star collapsed. That would explain their composition, the nickel vapor, the cyanide traces, the absence of water. It would make them siblings, relics of a destroyed world adrift in the quiet gulf between suns. But the geometry, the sheer alignment of their paths, remained the thorn no theory could pull free. Even the press began to notice. The headlines returned, cautious at first, then more daring. NASA confirms second interstellar comet, they said. Déjà vu in the dark. But when journalists asked whether the agency considered the two objects related, the response was the same as always. We continue to study the data. That phrase, simple, bureaucratic, safe, became the symbol of a new kind of silence. Not denial, not ignorance, but a pause. A long, deliberate hesitation before the next sentence. Meanwhile, behind closed doors, whispers of new evidence began to surface. A team analyzing high-resolution data from the Mars Trace Gas Orbiter noticed something peculiar in their scans of 3I Atlas's remnants, a faint metallic reflection, barely perceptible, located within the coma. It was dismissed as an artifact at first, a calibration error, but when similar readings appeared in 4I Solis, in the same spectral band, the coincidence became difficult to ignore. Metallic reflections, after all, are rare in comets. And so a quiet debate began to grow. Was this the echo of mineral inclusions, or the glimmer of something built? The idea was dangerous. It brushed against the edge of what science was willing to entertain. To suggest artifice is to step beyond data and into narrative, and narrative, once invoked, cannot easily be contained. So the findings were held back, buried in technical appendices and minor conference notes, where only the most curious would find them. But the world was changing. Information no longer stays buried for long. Independent analysts, armed with public data, began to reconstruct their own models, and what they found only deepened the mystery. The coma's geometry, when plotted in 3 dimensions, revealed an internal symmetry unlike any previously observed. It wasn't random expansion. It was layered, fractal, recursive, as though the gas itself remembered the structure of the body it left behind. And in that structure, some claimed to see order. Perhaps it was coincidence. Or perhaps it was the whisper of something else, something older than science and more deliberate than chance. The narrative that followed split the scientific community into quiet factions. On one side were those who insisted on restraint, that to interpret too soon was to risk delusion. On the other were those who believed that restraint, too often, was just another form of fear. For the public, though, the question was simpler. 2 objects, 2 signatures, 2 silences. How many times can coincidence repeat before it becomes intention? And so, once again, the sky divided us between believers and skeptics, dreamers and empiricists. Yet, in truth, both sides shared the same longing. To know whether we are truly alone in the dark, or whether, hidden in the cold mathematics of motion and light, there is evidence that the cosmos has been speaking all along. As 2025 gave way to its final months, something remarkable occurred. The Vera Rubin Observatory detected a 3rd anomaly, a new visitor, faint and slow, tracing a path that mirrored both 3I Atlas and 4I Solis. The data was incomplete, the trajectory uncertain, but already the whispers had begun. A pattern of 3, and perhaps, just perhaps, this time the universe would not remain silent. A pattern of 3. That phrase alone was enough to change the tone of everything that came after. Because, you see, 1 anomaly can be dismissed as noise, 2 can be written off as coincidence, but 3? 3 begins to whisper of structure, of rhythm, of intention hidden within the mathematics of chance. When the Vera Rubin Observatory released its preliminary data, there was hesitation, as if the astronomers themselves were afraid to disturb the silence that had settled over the scientific community since the last 2 interstellar visitors. But eventually, the announcement came. Another object, faint and cold, entering the solar system from the same quadrant of space, following an eerily familiar curve. They named it 5I Calis. At first, there was disbelief. Some thought it was a data artifact, a misidentification, or a residual echo of 4I Solis that the algorithms had misread. But the signal held. The orbit sharpened, the numbers converged, and the truth emerged, slowly, patient, inevitable, undeniable. It was real. Another interstellar body, arriving from the same direction, tracing a trajectory within 2 degrees of the paths carved by 3I Atlas and 4I Solis. The timing, too, was impossible to ignore. Each arrival had occurred roughly 350 days apart, a steady pulse across the fabric of space, almost a calendar written in starlight. When the first images came through, the pattern deepened. 5I Calis glowed faintly in infrared, just enough for the James Webb Space Telescope to catch a spectral trace. Carbon dioxide, again, led the composition strong and unwavering. Water was nearly absent. Nickel and cyanide, once more, lingered in the margins. The same chemical signature, repeated like a refrain, a song of frozen gas and metal echoing across the cosmos. This time, though, there was something new. The coma surrounding 5I Calis wasn't simply vast, it was alive with motion. Patterns formed and vanished like tides, swirling filaments of gas that stretched across hundreds of thousands of kilometers. The data analysis showed waves of emission radiating outward in perfect intervals, regular, precise, unexplainable. If 3I Atlas had whispered and 4I Solis had pulsed, then 5I Calis sang. Scientists called them coherent oscillations. In ordinary comets, activity fluctuates randomly, driven by uneven heating or surface collapse. But here, the energy release followed a rhythm that seemed almost mechanical. Not perfect, but deliberate, too consistent for chaos, too irregular for automation. Like the breath of something ancient, measured in millennia. NASA, careful as ever, acknowledged the discovery with careful neutrality. An intriguing and consistent pattern, the official release said, deserving of further observation. But, beneath that calm, the agency's internal discussions had turned electric. Reports leaked that the Vera Rubin team had found another layer of the mystery. The coma of 5I Calis was not only vast, it was asymmetrical in a way that defied every known physical model. On one side, the gas was faint and diffuse. On the other, it formed a dense, curved filament, a plume stretching almost 300,000 kilometers, bending subtly, as though tracing an invisible path. The structure was astonishing not for its shape, but for its stability. It didn't shift with solar wind, didn't distort under radiation pressure. It held, steady and unyielding, as if it were guided by a force no one could name. At a press briefing, a young astrophysicist from Chile hesitated before answering a journalist's question. Her voice was quiet, uncertain. "It's not a jet," she said. "It's not a tail either. It's a geometry that shouldn't exist in nature." The phrase spread quickly, unnatural geometry, picked up by tabloids and dismissed by official channels, yet impossible to erase once spoken. The mathematics confirmed what intuition had already felt. The curvature of the plume matched a logarithmic spiral, one of the most elegant and recurring forms in nature, found in galaxies, hurricanes, shells, and flowers. But this spiral didn't open outward. It folded inward, toward the nucleus. A reversal of entropy, a pattern that seemed to concentrate energy rather than release it. A phenomenon that, by every law of thermodynamics, should not have been possible. You see, that was the moment when scientists stopped arguing about coincidence and started whispering about causality. The question changed from, why does this look deliberate, to what would it mean if it were? The leading hypothesis was that the objects were fragments, shards of a once larger body that had crossed interstellar space together. Perhaps a planet, shattered by a dying sun, or the remnants of a rogue world that had drifted too close to a black hole. Over eons, its pieces might have been stretched into a thin stream by galactic tides, now intersecting our solar system in sequence. That theory explained the timing, the orbits, even the composition, but not the geometry, not the balance, not the way each fragment seemed to act as though guided by invisible hands. One paper from a research group in Japan proposed that these bodies might be resonant, responding to a shared gravitational rhythm, perhaps the echo of a long-vanished binary system. Another, from a team in Canada, suggested they might carry magnetic memory, that their metallic cores were aligned in such a way that they interacted subtly with the sun's magnetic field, creating the illusion of control. But there were others who ventured further. They asked whether the universe itself might remember. That, I suppose, is the most haunting idea of all that. Matter can carry memory, that particles shaped by ancient processes can retain the imprint of intention, repeating it across light years without ever knowing why. Perhaps 3I Atlas, 4I Solis, and 5I Calis were not messages in the deliberate sense, but echoes, resonances of a design long lost to time. The universe, after all, is full of ghosts that don't know they're haunting. Still, there was one more mystery to come. As the analysis of 5I Calis deepened, the Vera Rubin team discovered a faint fluctuation in its brightness that didn't correspond to any known rotation. A subtle dimming and brightening, repeating every 23 hours, almost like a signal. When plotted, the pattern revealed a strange waveform, 3 peaks, followed by a pause, then one long descent. It wasn't random. It was structured, deliberate, almost mathematical. For a moment, people held their breath. Was it a coincidence of light and dust? Or had we, at last, stumbled upon a cosmic rhythm not born of physics, but of purpose? Radio telescopes were trained on the object. Arrays across the globe listened for anything, any whisper, any pulse, any modulation that might hint at communication. What they found was silence, but not the empty kind. It was a silence dense with implication, like the pause before a word. When the James Webb team released their latest images, the comet's coma appeared stranger still. The inner core was darker than expected, absorbing more infrared radiation than it reflected. Something solid, perhaps metallic, lay buried beneath the veil of gas. But there was no way to see it clearly. Every attempt to model its structure led to the same unresolved conclusion: a dense core, oddly smooth, rotating too slowly to match the data. It was as though the nucleus was shielded, wrapped in a layer that resisted analysis. And then, quietly, the object began to fade. By the end of 2025, it had slipped beyond detection range. The 3 visitors, once so radiant, were gone. All that remained were their traces, ratios, orbits, patterns, silence. But the pattern, once seen, could not be unremembered. In academic circles, it became known as the triad hypothesis. 3 objects, 3 anomalies, 1 direction. Some said it was a cosmic coincidence, others a message written across millennia. The debate grew philosophical, almost spiritual. If the universe does speak, what language does it use? Is mathematics its grammar, light its voice? Or are we simply anthropomorphizing noise, hearing intention where there is only entropy? And yet, there was one final, quiet observation that few noticed at first. The trajectory of 5I Callis didn't quite match the others. It tilted slightly north of the ecliptic before vanishing, like an arrow that had missed its mark by a fraction. When astronomers extended that line forward, projecting where it would travel in the coming centuries, they noticed something almost poetic. The path intersected the orbit of a nearby star, a small red dwarf, less than 15 light-years away. The calculations showed that, in roughly 20,000 years, 5I Callis would pass through that system's outer debris field. To us, it meant nothing. But to the cosmos, perhaps it was a handoff, a relay, a continuation of whatever motion began long before our species learned to look up. And so, once again, we are left with silence. The kind that hums with possibility, the kind that reminds us that discovery is not a conclusion but a dialogue. Because somewhere out there, beyond the orbits of our comprehension, beyond the reach of even the most sensitive instruments, something else is moving slow, patient, unseen, carrying the same faint rhythm in its wake. And perhaps, when it arrives, we will finally understand why the universe keeps sending these echoes back to us, one by one, like messages meant for minds still learning how to listen. And perhaps, when it arrives, we will finally understand why the universe keeps sending these echoes back to us, one by one, like messages meant for minds still learning how to listen. For weeks, astronomers around the world stared at their screens in disbelief. The discovery of 3 interstellar visitors in such precise alignment had already stretched reason to its limits. But when the 4th candidate appeared, a faint trace on the horizon of the heliosphere, probability itself seemed to crumble. The models said it could not happen. The universe, apparently, disagreed. At first, it was dismissed as sensor noise, a flicker in the digital static. But the flicker returned, then strengthened, then moved. Slowly, gracefully, unmistakably. The trajectory matched the pattern almost perfectly, same inclination, same retrograde motion, same improbable proximity to the ecliptic plane. And yet, there was a subtle difference. Its eccentricity was slightly higher, 6.2 instead of 6, and its velocity on entry slower, as though it were gliding rather than falling. That detail unsettled many. A hyperbolic orbit, yes, but one that behaved with a strange reluctance, decelerating near the solar boundary in a way that defied the expected pull of gravity. It wasn't enough to claim anomaly, not yet, but it was enough to wonder. The object was designated 6I Seraph. Even before the official confirmation, observatories across Earth, Mars, and the Moon had turned to watch. The James Webb Space Telescope again shifted its gaze, its mirrors angling toward the inbound visitor. The Vera Rubin team tracked its motion from Chile, and for the first time, data from all three previous visitors, Atlas, Solis, and Callis, were re-examined together. What emerged was a pattern so exact it left no one comfortable. Each arrival was separated by nearly the same interval. Each approached from the same galactic vector, within half a degree. Each carried the same composition: dominant carbon, dioxide, faint water, trace nickel, cyanide. Each displayed symmetric gas release. And now, with Seraph, the pattern continued. But the new data revealed something deeper, something geometric. When the orbits of all four were plotted in 3 dimensions, they converged at a single point, far beyond the Sun, a region near the outer edge of the Kuiper belt, where no known object or gravitational anomaly existed. The lines of their paths met there, forming what one analyst described as a cosmic intersection, as if the comets were fragments flung outward from a single event long ago. Yet their timing was too precise for that. The intersection was not only spatial but temporal. The trajectories implied they had been traveling together at different velocities for millions of years, only to arrive here, near our world, almost simultaneously. Coincidence had ceased to be a viable word. NASA's response was quiet professionalism, the same steady tone that now felt almost rehearsed. "We are studying the unusual orbital clustering," the press release read. "At present, there is no evidence of artificial influence." But within the data divisions, scientists were uneasy. The algorithms used to calculate orbital probabilities were returning errors, looping endlessly between unlikely and impossible. And that, perhaps, was the strangest thing of all. The universe was breaking our probability engines. One researcher, half in jest, compared it to rolling a dice and getting the same number 4 times in a row, except that in this case, the dice had 1 billion faces. As 6I Seraph approached the inner solar system, its brightness behaved erratically. For several days, it dimmed below detection, then flared again, with such intensity that some instruments saturated. The flare, when analyzed, revealed a brief but distinct emission of nickel lines brighter and purer than any comet ever observed. Nickel vapor, yes, but refined, stripped of impurities, as though the element had been separated by some natural process too perfect for randomness. That was when murmurs began to grow louder about the possibility of an internal heat source. Perhaps decay, perhaps friction, perhaps something else. But the models, again, refused to cooperate. Every variable, every simulation, failed to explain the sustained luminosity. And then came the realization that chilled even the boldest theorists. The 4 trajectories, when extended backward, didn't simply converge, they pointed outward again, beyond the Kuiper belt, beyond the heliopause, toward a single galactic coordinate, a point in space near the constellation Lyra. It was as though the comets were not coming from random directions, but from a fixed source, far beyond our system, a direction, a line drawn through the stars. R.V. Loeb called it an interstellar alignment of intent. He suggested provocatively that the objects might not be fragments at all, but couriers, natural or otherwise, following a shared trajectory from an ancient origin. The scientific community recoiled, as expected, but the idea lingered. It lingered because no one else had a better explanation, and so the whispers began again. If the universe were trying to tell us something, would we even know how to hear it? The closer Seraph came, the stranger its behavior became. Unlike the previous visitors, its coma was not a sphere, but an ellipse, stretched like a veil. And within that veil, oscillations pulsed with an almost mechanical rhythm. Every 8 hours, the gas density peaked, as though breathing. The pattern was so exact that, when converted to sound frequencies, it produced a tone, a single sustained note, too pure to be random. Of course, the idea that it might be deliberate was swiftly dismissed. Natural processes, after all, can produce rhythm. Thermal stress, rotational dynamics, sublimation cycles, these could all explain it. And yet, the tone persisted. It was during one of those observation sessions that a young physicist named Clara Havel noticed something strange. The intervals between brightness peaks matched the ratios of the distances between the orbits of the previous visitors, a sequence of proportional relationships that formed, when plotted, a harmonic scale. Not perfect, not musical in the human sense, but mathematical, the same relationships that govern planetary resonance, orbital stability, and, intriguingly, sound. Coincidence, of course, but the kind of coincidence that leaves a shadow. By now, the silence surrounding NASA's communication had become almost theatrical. Press briefings were postponed, interviews were cancelled. Even internal memos were filtered through public affairs channels. The agency wasn't hiding the data, they published everything. As always, but they stopped telling the story. It was as though they had decided that the best way to handle the extraordinary was to refuse narrative altogether. And in that void, stories grew. Some believed these visitors were part of a natural galactic stream, a river of ancient debris crossing through stellar neighborhoods. Others insisted they were probes, ancient relics drifting on trajectories set by intelligence long extinguished. A few even speculated that the objects were connected, bound by magnetic threads invisible to our senses, a kind of cosmic lattice extending across the void. But the truth, if there was one, remained hidden within equations. The eccentricity of 6I Seraph, that impossible 6.2, made it clear that the object was not bound by the sun's gravity. And yet, its motion remained eerily consistent with an invisible frame of reference, some gravitational field, perhaps, or something subtler, a memory of motion embedded within its own matter. As weeks passed, it became apparent that Seraph's path would take it dangerously close to Mars. Astronomers waited, eagerly, for this time there would be no ambiguity. The Mars orbiters were ready, their cameras aligned, their sensors tuned. It would be the closest observation ever made of an interstellar body. And then, for a few precious hours, the images arrived. At first, it looked ordinary, a glowing core, trailing its plume across the black. But when enhanced, the coma revealed faint striations, perfectly parallel lines extending from the nucleus, lines too orderly to be natural turbulence. They curved gently, spiraling outward, like threads woven into the fabric of gas. And in the center of it all, something darker, a shadow that moved against the direction of sunlight, as though reflecting nothing. When those frames reached Earth, the response was muted. The official explanation was camera interference. But those who saw the raw data knew otherwise. The geometry was too perfect, the symmetry too refined. And then, abruptly, communication from one of the Mars satellites went silent for 6 minutes. When contact was restored, all systems reported normal. The logs showed nothing unusual except one timestamp anomaly, a delay of precisely 6.2 seconds. The same number, the same echo. Coincidence? Again, always coincidence. Yet somewhere between all these coincidences, something larger was taking shape, an awareness that perhaps these were not just fragments of ancient rock, but fragments of meaning. That maybe, long before we existed, the universe had already written a story in motion and light, and we were only now beginning to read the first lines. And as Six-Eyes Seraph passed by Mars, turning its luminous face toward the sun, astronomers noted one last, unsettling detail. Its trajectory, though hyperbolic, seemed to curve ever so slightly toward the ecliptic, aligning once more with the plane of planets, as though choosing its path. By the time it vanished into the outer dark, that small deflection had become the subject of endless debate. Was it gravitational influence, solar radiation pressure, or had the object, impossibly, adjusted its course? No one could say. But somewhere, in a quiet observatory half a world away, a new alert appeared on the screen. Another light, faint and deliberate, entering from the same direction in the sky. And just like that, the pattern continued. Another light, faint and deliberate, entered from the same direction in the sky. By then, the world had grown used to these strange visitors, used to the whisper of anomalies that came and went like passing dreams. And yet, each new arrival carried a deeper weight, a gravity of meaning that no amount of repetition could soften. This time, though, something felt different. The silence surrounding the discovery was heavier, as though every observatory, every agency, every scientist involved had collectively chosen to breathe more quietly. It was found on a cold morning in late autumn, its signal faint and steady, moving just as the others had hyperbolic, retrograde, perfectly aligned with the thin plane of our planetary system. But its trajectory was narrower, sharper, as though tracing the invisible spine of the ecliptic itself. Even before it was confirmed as interstellar, the whispers began. A fifth object, a continuation of the impossible sequence. A pattern becoming a statement. The designation came quickly, 7I Erebus. The name suited it. Erebus, the darkness beneath the world, the shadow between worlds. It was dimmer than its predecessors, almost invisible in optical wavelengths, but bright in the infrared. It radiated not heat, but an eerie consistency of temperature, a thermal balance that seemed to ignore the sun's influence. Unlike 3I Atlas, which had awakened in violent bursts of gas, Erebus remained calm, a perfect silence sliding through the heliosphere, its coma so thin it was almost theoretical. At first, this calm was taken as proof of dormancy. Perhaps the comet was inert, long dead, carrying only the residue of ancient reactions. But when the James Webb Space Telescope turned its attention toward it, the spectra told another story. Beneath the surface, faint but unmistakable, were the same chemical fingerprints: carbon dioxide, nickel vapor, cyanide, the same ratio, the same ghost of a formula that had followed us across 4 previous visitors. And yet, this time, something was missing. The water. Not faint, not weak, gone. No hydrogen emission, no trace of hydroxyl radicals. The molecular lines were silent. It was, in a sense, pure. A body of almost perfect carbonic composition, drifting through space without the faintest breath of water. A comet that had been stripped of the most universal molecule of life. And that, well, was what truly unsettled the scientists. Because you see, water is the constant. It is the memory of formation, the relic of warmth. To find an object so devoid of it was to find something that had never known heat, never known proximity, never known the comfort of a star. It was as if Erebus had been born in the eternal night between galaxies, a child of cold so absolute that it remembered nothing but stillness. For some, that purity made it the most alien object ever recorded. For others, it was a clue a step closer to understanding the pattern. If the previous comets were fragments, perhaps Erebus was their origin. The parent body, long scattered across the void, finally revealing itself. But if so, where had it come from? And how could its fragments, traveling at different velocities across billions of kilometers, arrive here, now, within the span of a few human years? The answer, as always, refused to fit the equations. NASA's public tone grew even more subdued. Press releases were now little more than lists of numbers. There were no adjectives, no speculation. The word anomaly disappeared entirely. It was replaced by phrases like unmodeled phenomenon and unclassified trajectory. Even the scientists, those who had once argued passionately in papers and conferences, seemed quieter. Perhaps it was fatigue, or perhaps the data had reached that dangerous point where knowledge becomes indistinguishable from faith. Avi Loeb, meanwhile, was not silent. He published a new essay titled The Silence of Certainty, arguing that Erebus might represent the threshold between natural and non-natural origin. He didn't say artificial. He didn't need to. The implication was already there, written between the words, and for that, the essay was criticized, debated, ignored, and quietly read by everyone. But then came the numbers that no one could ignore. Erebus's orbit was hyperbolic, yes, but it intersected the ecliptic at precisely 5 degrees, the same angle as 3I Atlas. Not approximately, not within margin, but exact. The odds of such an alignment occurring by chance were less than 1 in 2,000. Add to that the retrograde direction, the repeating chemical composition, the synchronized timing, and the odds fell into absurdity. The probability was so small it ceased to be meaningful. The line between coincidence and coordination blurred into nothing. At some point, someone no one knows who ran a backpropagation simulation of all 5 known interstellar objects. The model extended their orbits backward through space, accounting for solar influence, galactic drift, and gravitational perturbation. What it revealed was simple and impossible. They all came from the same place, not approximately, not within error margins, the same galactic coordinate, a region of space near Lyra, the same place that 6I Seraph had pointed to before it disappeared. For the first time, the scientific community found itself staring at a pattern too clean to ignore. And yet, to call it intention was still forbidden. Intention belonged to minds, and minds were things we still believed the universe held only one of. Still, the question grew louder. Was something or someone sending these? Erebus passed near Mars, as the others had. This time, all instruments were ready. The trace gas orbiter, Perseverance, even the long-dormant InSight seismometer were repurposed to capture data. And for the first time, a direct observation of the nucleus was made. It was not what anyone expected. The images showed a near-perfect sphere, smooth, almost metallic in sheen, wrapped in a faint veil of dust. No ridges, no fractures, no craters. Its albedo was wrong, too high for carbon, too low for ice. When sunlight struck it, the reflection was polarized, uniform, as though bouncing off an ordered lattice. It was beautiful, in a way that defied familiarity. The object rotated once every 6 hours. Its poles aligned almost perfectly with the ecliptic, and as it turned, faint ripples of gas escaped from symmetrical vents near the equator, not randomly, but rhythmically. When converted into a light curve, the emission formed a repeating waveform, identical in shape to that of 5I Calis. Patterns, always patterns. Even the coma around Erebus was disciplined. stretching not into a diffuse haze, but into a filament thin, luminous, bending inward toward the nucleus. It was as if the object were inhaling the light around it, not scattering it. And then, as it passed the orbit of Earth, something happened. For a brief span, just a few hours, radio telescopes around the world detected a faint modulation in the cosmic microwave background. A subtle oscillation, centered precisely on the frequency corresponding to Erebus's emission lines. It was not a signal, not in the human sense. It carried no information, no encoding, no message. But it was there, synchronized with the object's rotation, as if space itself were resonating with its passage. NASA's official stance was cautious. Unrelated interference, they said. But privately, within encrypted communication channels, the word resonance began to appear. A resonance not of sound, but of existence. By then, the media frenzy had reached its peak. The public wanted answers, scientists wanted certainty, and yet the most honest minds could only offer metaphors. One physicist described the pattern as the universe remembering itself. Another said, perhaps these aren't objects at all, but moments, fragments of a single event moving through time rather than space. You see, that's the thing about discovery. It doesn't always expand what we know. Sometimes it expands what we can't explain. Erebus passed behind the sun, vanished for several weeks, and when it reappeared, it had changed. The smooth surface was fractured, faint cracks visible like veins across its face. From one of those cracks, a plume of gas escaped a new element this time, faint traces of iron cyanide, never before observed in any comet. The chemical complexity deepened, the mystery widened, and then, as suddenly as it had appeared, Erebus began to fade. By late winter, its light was gone, swallowed by the deep sky. The pattern, it seemed, was over. But that silence, that exquisite silence, carried with it the weight of expectation. Because if 5 visitors could appear from nowhere, perfectly aligned in chemistry and motion, then there could always be a 6th. And somewhere, near the outer edge of the heliosphere, sensors began to hum again. Another trace, faint but steady, moving from the same quadrant of Lyra. Some called it coincidence. Others called it prophecy. But perhaps, well, it was neither. Perhaps it was simply the next line in a cosmic sentence still being written, letter by letter, across the cold expanse between stars. And this time, what was coming wasn't faint. It was brighter, faster, closer. And this time, what was coming wasn't faint. It was brighter, faster, closer. The first detection came from a deep space monitoring satellite stationed near the Lagrange point between Earth and the Moon. The signal was strong enough to saturate its sensors not with heat, but with motion. Something immense was approaching, its speed surpassing any of the previous interstellar visitors. At first, the team thought it was an error, a miscalibration caused by solar interference. But when the same object appeared in the James Webb data, its orbit confirmed the impossible. It was real. Its approach was not random. Its path cut through the exact region of space where 3I Atlas had first been detected, the same celestial corridor that had now become a kind of cosmic signature. Only this time, the angle of entry was steeper, the speed higher, as if whatever had released these bodies was running out of patience. The object was designated 8I Lyra. It was the brightest of them all. Unlike the quiet, ghost-like comas of the previous comets, Lyra shone with a steady intensity, not flickering, not chaotic, but controlled, like the glow of a lamp beneath a veil. Its light curve was unnaturally smooth, the kind of precision that normally requires engineering. And its spectrum, its spectrum was something that made even the most grounded scientists stop and stare. Carbon dioxide dominated as expected, but the secondary signatures were unlike anything seen before. There was a distinct emission line at a wavelength unaccounted for in any known molecular transition. Some thought it was an artifact of calibration. Others, reluctantly, called it what it appeared to be an organized modulation of light, a pulse. Every 11 minutes and 22 seconds, the intensity shifted. Not in brightness, but in frequency. A gentle oscillation that seemed too deliberate to be thermal in origin. It wasn't communication, at least not in the way we understand it. It was more like rhythm, the repetition of an idea through light. And then came the shape. Lyra's coma was no longer spherical, nor even elliptical. It was structured. The gas formed bands, spiraling outward like the arms of a galaxy. Within those arms, high-resolution imaging revealed pockets of luminosity nodal points, arranged in a geometry that could not be explained by jets or rotation. The pattern, when translated into polar coordinates, resembled a mathematical sequence, a logarithmic spiral with constant angular velocity. Nature loves spirals, yes, but not ones that turn inward. It was a mirror of 5 Icalis, the same inward folding curve, now brighter, sharper, closer. As though something had decided to repeat the same message, only louder. NASA's official communication this time was late. Weeks passed before any statement was made. By then, the data had already leaked, passing through private observatories and open-source tracking networks. The silence from the agencies became its own kind of language, not denial, not suppression, but reverence. In the meantime, the public turned its gaze upward. The news called it the Harbinger. People began to wonder whether this sequence of arrivals was natural or intentional, whether the universe was sending not random stones but carefully timed reminders. The line between science and mythology blurred, and yet, beneath the noise of speculation, the scientists continued their quiet work, sifting data from wonder. The most extraordinary finding came from the Vera Rubin Observatory's long-exposure imaging. When they mapped the path of 8I Lyra against the positions of the previous visitors, something stunning emerged. If the trajectories were extended outward beyond the Sun, beyond even the edge of the heliosphere, they converged once more not at a single point, but at a line that stretched through space like a filament, running straight toward the constellation Lyra. The same name, the same direction, the same quiet pull. It was as though all these objects were fragments of something vast, a system, a chain, a procession crossing the galaxy. Each one separated by unimaginable distances, yet still connected, like pearls on an invisible thread of gravity and time. As Lyra approached, its brightness increased tenfold. The gas emissions, however, did not. This was the first sign that something was wrong, or perhaps something intentional. Normally, a comet's glow comes from the reflection of sunlight off its expanding coma. But here, the luminosity rose even as the coma thinned. It was not reflecting, it was radiating. Spectroscopic analysis showed a strange shift in the infrared, not redshift or blue shift, but a phase modulation, as though the light were passing through a medium not entirely physical. Some physicists proposed coherent light scattering, others, plasma resonance. But the simplest explanation was the one no one dared write. It looked like energy being released in intervals, like a machine breathing. Avi Loeb's team at Harvard published a preliminary note warning that Lyra exhibited non-natural photometric modulation. It was the most cautious way possible to say what everyone was already thinking. And for that, the paper was met with the same combination of curiosity and ridicule that had greeted every mention of intent. Yet behind the closed doors of research centers, the tone was no longer dismissive. For the first time, people were genuinely afraid. Lyra was moving faster than any of the previous visitors, 45 kilometers per second relative to the Sun, and its trajectory would take it perilously close to Earth's orbit. Not a collision course, Not yet, but close enough that the entire planet would see it in the night sky. A comet that shone not with reflected sunlight, but with its own strange, measured fire. And that, perhaps, was the moment humanity finally looked up again. For weeks, the world watched as a pale thread grew across the heavens, faint at first, then radiant, then terrible. In its stillness, the tail was short, almost non-existent, but the head glowed with an unchanging brilliance. It did not flicker, it did not shimmer, it simply burned, constant as thought. When the James Webb Space Telescope aligned its instruments for one final, close-range spectrum, the data it returned was unlike anything seen before. The emission line that had puzzled scientists earlier split into harmonics, precise intervals of frequency corresponding to ratios found in orbital mechanics, music, and geometry. The pattern repeated exactly every 11 minutes and 22 seconds. And then, one day, it stopped. The modulation vanished, the object dimmed, and for a brief, unsettling moment, the space around it seemed to shimmer a distortion of light, as though the vacuum itself had bent in acknowledgement. Instruments on Earth registered a subtle gravitational anomaly, a minute deviation in satellite orbits lasting less than a second. Then, silence. The comet continued, on its path, unchanged in direction but diminished in brightness. It drifted past Mars, then the asteroid belt, and then, like all the others, out toward the darkness beyond Neptune. But it left behind something new, an echo. Radio telescopes across the globe began picking up a faint background fluctuation, repeating at the same interval as the comet's modulation. It wasn't a signal. It wasn't data. It was more like the universe itself had learned a rhythm and decided to hum it back. For days, every observatory recorded the same pattern. Then it faded, leaving behind a silence so deep it seemed almost conscious. And yet, in that silence, something shifted in the collective understanding of what had just unfolded. The old certainty that these objects were mere coincidences finally crumbled. The pattern had grown too complex, too structured, too beautiful. Some began to suggest that these visitors weren't messages at all, not communication, but choreography. The universe was performing something, a sequence of events unfolding across scales so vast that our species was only now beginning to see its outline. Each object, each comet, each anomaly was a single frame in a film far older than us. NASA never released an official conclusion. The last public statement about 8I Lyra was simple. The object is outbound. All parameters within expected variation. But within the private community of researchers, a quiet conviction took hold that something extraordinary was beginning. Because when the orbits of all 8 visitors 3I through 8I were plotted together, they didn't just align, they formed a shape, a vast, graceful curve looping back toward the sun, almost as though the system itself were sketching an image across the sky. No one could see it, not with human eyes. A spiral not random, but deliberate, a cosmic fingerprint. And at its center, the sun was no longer alone. Because as Lyra faded, new instruments began detecting something else, a faint, persistent glow just beyond the orbit of Neptune. Not a comet, not a reflection, but a steady, constant point of light. Unmoving, waiting, and perhaps, this time, what was approaching would not merely pass us by. And perhaps, this time, what was approaching would not merely pass us by. At first, it appeared as nothing more than a lingering echo, a faint dot of light, stationary and silent, just beyond the orbit of Neptune. Observatories catalogued it, measured it, and, for a while, assumed it was a background star caught in the slow movement of parallax. But the parallax never came. The light did not drift with the Earth's orbit as a star's would. It stayed still, too still. By the second month, The measurements were undeniable. The object was not fixed against the stars, it was moving, slowly, deliberately, inward. It was brighter than any known body in that region, and yet no telescope could capture its structure. Even the James Webb Space Telescope, with its vast sensitivity, recorded it as a perfect sphere of radiance, featureless and unwavering. NASA classified it as Object X9, a placeholder name, cautious and neutral, but the world preferred another, the Sentinel. Its presence carried a weight that no equation could quantify. Every analysis began with the same phrase: it should not be there. There were no known gravitational anomalies to account for its motion, no debris trail, no cometary emissions. And yet, somehow, it was glowing not reflected sunlight, but its own light, a steady emission in a wavelength just beyond human vision, sitting between infrared and microwave. The kind of radiation that doesn't just illuminate, but warms the void around it. At first, the energy seemed constant, but over the following weeks, instruments began to detect subtle variations, small pulses repeating at exact intervals. 11 minutes and 22 seconds, the same period that had defined 8I Lyra, the same rhythm that had echoed across the radio background months before. This was not coincidence. The scientists at the European Space Agency released the first spectral breakdown, and the findings stunned even the most stoic among them. The pulses were not random noise. They were harmonic frequencies layered upon one another in a progression that mirrored orbital ratios. Not a signal, not communication, but resonance, encoded in light itself. It was as if the object were vibrating in sympathy with the solar system, matching its gravitational rhythm note for note. For a time, the explanation was simple, or at least comforting. Perhaps it was a fragment from the same stream as the earlier comets, now slowed by the sun's influence. Perhaps its glow was thermal emission, a leftover from an impact or collision. But as data accumulated, the comfort evaporated. The energy output of the Sentinel did not decay. It increased, not dramatically, just enough to remind everyone watching that it was alive in a way that no rock or ice could be. Over the next few months, the world began to look upward again. People gathered in open fields, on rooftops, at the edges of cities drowned in light, trying to glimpse what no naked eye could see. News channels spoke in hushed tones. The governments issued statements promising calm, and yet, beneath that calm, there was a trembling sense of expectation, not fear exactly, but reverence. Because if this was not a natural phenomenon, then what was it? The first real shock came when the object's motion changed. Slowly, subtly, it began to accelerate, not falling toward the sun in the clean arc of gravity, but adjusting its path. Its velocity increased in measured increments, then stabilized. Each adjustment corresponded precisely to the orbital period of Neptune. It was not descending, it was synchronizing. When plotted against the trajectories of the previous, interstellar visitors, 3I Atlas through 8I Lyra, the pattern revealed something extraordinary. The Sentinel's current position sat at the geometric center of the spiral those objects had formed. The curve of their paths, once extended, converged on that single glowing point. It was as though all of them, across years and billions of kilometers, had been leading us here to this still, radiant presence waiting beyond the sun's domain. NASA refused to speculate, but in private channels, discussions turned philosophical. Some suggested it might be a natural alignment, a byproduct of galactic drift. Others proposed gravitational lensing, a distant object magnified by chance. But none of those theories could explain the rhythm, the light, or the deliberate synchronization. And then, as quietly as it had appeared, the Sentinel spoke, not in language, not in sound, but in a shift of its light. At precisely midnight Universal Time, on the first day of the new lunar cycle, the pulse pattern changed. The intervals lengthened slightly, forming a new ratio, one that corresponded to the orbital period of Earth. 11 minutes and 22 seconds became 11 minutes and 34. It was as though the object had noticed us. Astronomers verified it within hours. The signal repeated exactly, synchronized, not with the Sun, but with Earth's position in its orbit. And though no information was encoded, no message was hidden, the implication was undeniable. Whatever this was, it was aware. The news spread instantly. For the first time, there was no attempt to suppress or soften it. The world had been watching too closely. Within days, the object's image filled every screen on the planet, a perfect white sphere against the black, pulsing with steady rhythm. Conspiracy theories bloomed. Religious movements were reborn. Politicians tried to translate science into reassurance, and scientists tried, in vain, to translate wonder into logic. But perhaps what made it most unsettling was not what it did, but what it refused to do. The sentinel did not move closer. It did not send a signal. It simply existed, a quiet, steady presence at the edge of everything we thought we understood. For the scientists studying it, that stillness was the hardest part to bear. In the absence of motion, meaning becomes unbearable. Weeks turned into months. The pulses continued. 11 minutes and 34 seconds. Then, one night, they stopped. For 20 hours, the light held steady, no modulation, no fluctuation. It was as though the universe itself had paused to breathe. And then, just before dawn over the Pacific, a new pattern began. This time, the rhythm was not harmonic, it was sequential. When analyzed, the timing of the pulses corresponded to a series of prime numbers, not in light intensity, but in the spacing of each interval. 2, 3, 5, 7, 11. The sequence stopped there, repeating over and over in silence. It was the first moment in human history when the universe seemed to be counting. Some called it proof, others called it coincidence. A few whispered that maybe it wasn't communication at all, maybe it was recognition, a signal not sent to us, but past us. Perhaps it was an announcement meant for something else entirely. Because as the months passed, more strange observations began to emerge. A faint, almost imperceptible distortion was detected in the magnetic fields across the outer solar system. Not strong enough to disturb satellites or compasses, but measurable. And the shape of that distortion, when plotted, mirrored the same spiral geometry traced by the earlier comets. Every piece of data pointed to the same unthinkable possibility. The solar system was being mapped, but mapped by what and for what reason, no one could say. At the heart of it all, the sentinel remained silent, serene, patient. And yet, its presence began to affect the world in ways no scientific paper could capture. In classrooms and cathedrals, in laboratories and living rooms, people began to talk about meaning again, about the strange and humbling notion that the universe might not only be alive, but listening. And then, one evening, something remarkable happened. The light of the sentinel shifted once more, not brighter, not dimmer, but warmer. The frequency of its glow moved subtly toward the visible spectrum. For the first time, it became something the human eye could see without the help of instruments. In the clear skies of the southern hemisphere, a pale golden star appeared where none had been before. Not twinkling, not distant but present, steady, real. For a week, it hung there above the horizon, faint but unmistakable. And across the world, people looked up and wondered whether this was how contact would feel, not through words, not through messages, but through quiet invitation. NASA called it an atmospheric illusion, but no one believed that anymore. And when, on the 8th night, the light faded, it left behind a strange afterglow in the infrared, a path stretching inward from the edge of the solar system. Something was moving again. The Sentinel, at last, had begun to drift. Its trajectory was unmistakable. It was coming toward us. And as it did, the silence that followed was not fear, but awe, the kind that comes when the universe stops being an idea and begins to speak in presence. Because somewhere between the mathematics and the wonder, between what we could prove and what we could only feel, humanity understood what was happening. The waiting was over. Something was entering the light. It began to drift, slow and silent, like a thought breaking free from the mind that conceived it. By then, humanity had no illusions left. The Sentinel, the bright, impossibly constant sphere beyond Neptune, was no longer a rumor or a curiosity. It was a presence, a fact. The telescopes that had once strained to glimpse it now watched it in unblinking fear, as if the act of observation itself might provoke a reply. And then it moved. At first, the change was infinitesimal, a few arc-seconds of motion each night. But its vector was clear, inward. The object was descending toward the sun, following the ecliptic plane with perfect precision. It did not tumble or drift. It maintained orientation, one side forever facing the star, the other turned toward the black sea of interstellar space. Every instrument, every model, every equation said the same impossible thing. It was slowing down. Not from drag or resistance, there is none in the void, but by choice. A deceleration so smooth that it matched planetary velocities, as if joining a celestial dance that had been choreographed long before our species learned to count. NASA, by then, had ceased public commentary altogether. Their updates arrived as sterile bulletins, numbers, coordinates, brightness. But those numbers spoke of something beyond technology. The Sentinel had begun to orbit, not crash, not slingshot, not escape orbit. A stable, circular path just beyond the orbit of Neptune. The calculations showed an orbital period of exactly 200 Earth years. Too perfect to be coincidence, too symmetrical to belong to chance. When the first full-spectrum images came through, the astonishment was almost physical. The Sentinel was not a sphere at all, at least not in any familiar sense. Its light was deceptive, a halo concealing structure. Deep analysis revealed faint contours beneath the glow. Planes, ridges, geometries that obeyed neither randomness nor known physics. It was shape pretending to be light, and yet it seemed to breathe. Infrared sensors recorded a slow, rhythmic expansion of heat pulses that corresponded precisely to the 11-minute sequence that had once marked its distant presence. The pattern had returned, more defined than ever, as if the object was syncing itself once again with the system it had entered. You see, that was the moment when science, the kind built on humility and verification, began to hesitate. Because for the first time in recorded history, the data was indistinguishable from intention. At the same time, something else began to stir. Across radio observatories, the background hiss of the cosmos, that faint whisper left over from the birth of time, began to waver. Minutely, rhythmically, in step with the Sentinel's light. No signal, no voice, no code. Just resonance. It was as though the universe itself had leaned in, listening. And perhaps, we thought, that's what this was all along, not a message sent, but a conversation invited. In the months that followed, a quiet tension grew across the world. Nations disagreed on how to respond to something that made every border irrelevant. Some proposed radio contact. Others warned against interference. Philosophers spoke of patience, while the fearful demanded answers. But the object remained silent, luminous, unmoved by our curiosity. Until the day it turned. The Sentinel, after months of perfect alignment, rotated. Slowly, deliberately, Its axis shifted by 6 degrees, and for the first time, its light changed direction. The pulse, once symmetrical, became focused, narrowing into a beam that spread outward in a cone of soft radiance, not directed toward the Sunday toward us. The beam passed harmlessly through space, reaching Earth hours later as a faint fluctuation in the ionosphere. No damage, no interference, just light, pure, unmodulated, and yet curiously alive. For several seconds, radio frequencies across the planet oscillated in unison. The same harmonic intervals that had followed the comets echoed again. Ratios of motion, rhythm, gravity, and time. And then, silence. The next day, the Sentinel's pulse resumed but altered. 11 minutes and 22 seconds had become 11 minutes and 12. A small change, almost meaningless, unless, of course, one considered that 11 minutes and 12 seconds was the exact orbital resonance of Earth and Venus. It was as though the object had recalibrated itself, tuning to a new frequency, a new harmony. NASA never issued a statement. ESA called it coincidental photometric variation, but everyone knew what it meant. It had seen us. In the following weeks, a strange phenomenon swept across global magnetic readings. Not chaos order. The fluctuations followed the same intervals as the Sentinel's pulse, rippling through the planet's ionosphere in synchronized waves. The Earth, it seemed, had become an instrument, resonating faintly in reply. One night, a small observatory in Chile recorded something extraordinary. When the Sentinel's light reached its peak, a faint, secondary glow appeared high in Earth's atmosphere, a shimmer, almost invisible, matching the object's pulse in perfect rhythm. It wasn't a reflection, it was a response, and that, well, changed everything. For the first time, humanity faced not the question of if we were alone, but why we were being watched, and by what. The idea of communication had always been built on assumption that messages must be words, signals, data. But what if contact could be made through resonance, through synchronization, through shared patterns of motion and energy? Perhaps this was not about information, but about alignment. Maybe the universe didn't speak in language at all. Maybe it sang. The Sentinel, now in perfect orbit, continued its quiet symphony. Every pulse, every harmonic, seemed to ripple through the solar wind, through the fields of gravity that cradle our planets. The entire solar system began to hum in frequencies so subtle they were detectable only by the most sensitive instruments. And yet, some insisted they could feel it. Reports began to surface subtle, unprovable sensations among those living in remote observatories or aboard spacecraft. A faint pressure behind the eyes, a feeling of déjà vu when gazing at the stars, dreams of light that carried memory instead of words. You see, the deeper mystery wasn't that something had entered our system, it was that something within us had begun to awaken to it. Astrophysicists studying the orbital mechanics of the Sentinel soon realized that its path wasn't arbitrary at all. Every resonance it produced, every interval of light and magnetism, corresponded not only to planetary orbits, but to the ratios found in quantum spin. The hidden harmonies that bridge the smallest and largest scales of existence. That revelation was almost too poetic for science to bear. Because if that pattern held true, then the Sentinel wasn't merely here to observe, it was performing something. Reenacting a structure that exists everywhere from atoms to galaxies as if to remind us that we are part of the same music. Still, there was one more secret it kept. At the moment of its greatest brightness, when the resonance between Earth, Venus, and the Sentinel reached perfect synchronization, a faint transmission was detected, not radio, not light, but gravitational. Ripples, subtle but distinct, emanating outward, not from the object's surface, but from its center. Those ripples carried a pattern. When decoded, they formed a map, not of space, but of motion. Paths, arcs, spirals, lines of travel extending beyond the solar system, converging on a single distant point near the galactic plane. The same direction from which every interstellar visitor had once come. Lyra. The implication was staggering. The Sentinel wasn't a messenger, it was a node. A part of something vast and interconnected, a structure spanning light years, whispering through gravitational harmonics. Perhaps a network, perhaps a memory, perhaps a consciousness older than stars. And now, one of its voices was here, in orbit, singing to our Sunday. The next weeks blurred into wonder and quiet dread. The glow of the Sentinel intensified, bathing Neptune's orbit in a soft, pale light. And then, for the briefest of moments, it shifted not in position, but in tone. A single pulse, lower, slower, resonated across the void. Every observatory, every satellite, every listening post recorded it. The waveform, when translated into audio, was haunting a descending hum that faded into silence. But buried within that hum, when the frequencies were stretched 1,000-fold, was a pattern unmistakably familiar, a voice, not speech, but a rhythm that mirrored a heartbeat. And then, faintly, another echo joined it, not from the Sentinel, but from deep within the Earth's own magnetic field. The two rhythms aligned for an instant, and in that instant, for the first time, humanity was no longer just observing the cosmos, it was part of it. The Sentinel dimmed again, its light receding as it slipped into a darker, quieter phase. But we knew, now, that it was not the end. It had not come merely to reveal, but to prepare. Because even as it fell back toward the shadow of Neptune, telescopes began to register something else. Another light, far beyond, stirring on the edge of detection. Something vast, slow, and deliberate. And if the Sentinel was a messenger, then what was coming next might be the one who sent it.